is the CBS Evening News. With Dan Rather reporting from CBS News headquarters in New York.
The Nobel Prize in Medicine was awarded today to 3 U.S. researchers. Their pioneering chemical and biological discoveries.
In Sweden today, the Nobel Prize for Medicine has been awarded to 3 American scientists. Robert Furchgott, Louis Ignarro, and Farid Murad were recognized for discovering.
The 3 men are being honored for their research into the role of the chemical compound nitric oxide in the human cardiovascular system.
Here at home, 3 American scientists are celebrating their shared Nobel Prize in Medicine.
So how does one find out that they've won the Nobel Prize?
You get a phone call at about 4 o'clock in the morning, which happened yesterday morning, obviously.
And were you expecting it?
You never expect it. As a scientist, you hope that that might happen in your lifetime, but it's always a surprise, I'm sure.
Years ago, Albert Einstein said, "The most beautiful thing we can experience is the mysterious." Whether that mystery is the secret of the universe or the puzzle of life itself, scientists today continue to explore the beauty of creation. Science has wrought miracles and marvels. Wonders scarcely imaginable to our grandparents have become commonplace. The Nobel Prize, the highest accolade in the world, is recognition of a scientist's voyage of discovery. The Nobel Prizes would not even exist but for one thing, the explosive power of dynamite.
My greatest joy came when I very successfully built my first small bomb.
Alfred Nobel, the Swedish inventor and industrialist who created the prizes, owed his fame and fortune to the deadliest of discoveries. Despite the hazards, Nobel harnessed the volatile chemical nitroglycerin. The world changed overnight. But nitroglycerin has other uses too. In later life, Nobel was prescribed the same substance for his heart problems.
It was found by the clinical people, physicians, that this drug was quite useful in relieving myocardial pain or angina.
The munitions, the dynamite workers would go to work on Monday morning and get vascular headaches like migraine. They dilate the blood vessels in their brain and head. And that's what migraine is all about. You dilate those vessels, you get headaches. By the end of the week, their headaches went away because they developed tolerance. That then led to its use in angiopaths.
And perhaps the most ironic part of the story is the fact that Alfred Nobel himself developed angina, and the very drug he discovered as dynamite was prescribed to him, and he refused to take the drug. I guess he didn't really believe how clinically successful the drug was being found to treat angina.
Nobel's concerns may have been justified. It was not until nearly 100 years later that someone stopped to ask why nitroglycerin helped with chest pain, and won a share of the Nobel Prize for Medicine for doing so. Farid Murad, a doctor and pharmacologist, now based at the University of Texas, began his analysis of the way in which nitroglycerin works in the late 1970s.
It was exciting to figure out, although this drug had been used for probably more than 100 years, that we now figured out its mechanisms of action. And what these drugs do is permit these compounds under the right conditions of the tissue to generate nitric oxide.
Murad not only showed that nitroglycerin acts by releasing a gas called nitric oxide, he theorized that it acts as a messenger molecule, sending out signals to the countless cells that make up our bodies and telling them how to behave. The discovery caused a sensation. Nitric oxide is a known free radical, a common and toxic pollutant.
My colleagues thought we were crazy. I thought it was wonderful, exciting chemistry. free radicals are pollutants out of car exhaust and cigarette smoke and deplete ozone in the atmosphere and all that sort of stuff. There is a huge literature as a pollutant and intoxicant. And now we saw for the first time that a free radical, nitric oxide, could be beneficial and transmit information.
If we hadn't found that nitroglycerin works via nitric oxide, I really think that we would still view nitric oxide as being the major pollutant in the air over Los Angeles or London or wherever.
It was one thing to discover how drugs like nitroglycerin might work. But if nitroglycerin acts as a messenger, what messages does it deliver? The answer to that came from Dr. Robert Furchgott, a pharmacologist in New York. Furchgott always had an inkling his work would lead to something.
2.5 years ago, I had occasion to look up nitric oxide. Then, just by chance, I looked across at the opposite page, and there was Nobel, Nobelist, Nobel Prize. And practically, when the dictionary is closed, Nobel Prize and nitric oxide almost kissed one another. And I said, maybe it's an omen.
Experiments on blood vessels in Furchgott's laboratory often gave contradictory results. He found he could cause the smooth muscle surrounding blood vessels to expand or contract, but only if the endothelium, the lining of the blood vessel, was intact. The implication was that this lining was releasing a messenger that acted on the muscle cells. This messenger was dubbed EDRF, endothelial relaxing factor. And now the search was on to identify this mysterious molecule.
It took almost an embarrassingly long time to find out what the agent was. We did not find out that the agent was nitric oxide until 1986, largely because nitric oxide was considered a toxic agent. How could it be something that was important in controlling circulation?
Dr. Luis Ignaro at UCLA had been studying the effects of nitric oxide ever since Murad's revelation and was fascinated by the similarities between nitric oxide and Furchgott's EDRF.
We did the key experiment. We took a nitric oxide, which actually is supplied as a gas in a cylinder, and we actually injected it as a small stream of bubbles into organ chambers containing strips of coronary artery. And lo and behold, we noticed that it caused a dramatic relaxation of that smooth muscle, and therefore the pressure within the vessel would drop. So once we did that very first experiment and noticed that nitric oxide was a very potent agent in relaxing the smooth muscle, we knew that we had it.
By 1986, the stage was set. Ignaro knew he had unraveled the identity of Furchgott's EDRF and planned to tell the world at a medical conference. What he didn't know was that Furchgott had solved the problem too.
I presented all my evidence that EDRF was nitric oxide, and much to my surprise and joy, both at the same time, Bob Furchgott presented evidence which was completely different than mine, that EDRF might be nitric oxide. These two hypotheses, which we presented within 30 minutes of one another, certainly was the highlight of that conference back in 1986.
They professed and predicted that EDRF was going to be nitric oxide. And that then brought the whole field together, and the field took off and went bananas.
The discovery that a gas once derided as an environmental menace is actually a medical marvel led to an explosion of work in the field. But nowhere has the effect been felt so strongly as in the treatment of premature babies suffering from the life-threatening condition pulmonary hypertension.
The letter that I appreciated most came from a woman in California who sent a picture of her daughter, who's, I believe, about 4 months old. They were very expert perinatal pediatricians who worked with her, with the daughter, and used the nitric oxide inhalation. And she felt that she should write me to tell me that our discovery about nitric oxide was something that saved her daughter.
There are just so many things that are going to blossom and happen in the next decade or two. It's immediate life-saving ability in the intensive care unit with premature babies. its potential application for blood pressure maintenance, for heart failure, for cancer therapy, for new approaches to inflammatory diseases. And a lot of us would love to cure AIDS. A lot of us would love to cure cancer, heart disease, stroke, dementia. That's all doable. Nitric oxide plays a role, perhaps, in almost all those fields.